All right, so welcome to the office hours tonight. The topic that we're going to focus on are systems of equations. Last week, we worked on a bunch of different strategies, and one of those strategies was Desmos, basically how we could um, sub plug things into Desmos. So systems of equations is something that goes well with Desmos, but tonight we're going to focus on more of the other concepts. I'll talk about when you could use Desmos, but I want to make sure that we also know the other ways to solve systems. And before we do that, let's go over our challenge problems for the week. So these are not necessarily related to the topic. They are just hard problems that I have found. So we take a look at number one, and we have the equation of a line. And they say the graph represents the equation. And they give us something like this, which looks a little bit confusing, but just notice that it is just in y equals mx plus b form. And this b is like a different b, so don't worry about that. So what we're going to do is just ignore this for now. So a lot of times they give you something in the problem that looks a little strange. Just kind of ignore it and see what you can figure out. So what we can do is we could just come up with the equation of this line on our own. And we would do that by finding m and b. Well, b is easy. That's the y-intercept. So in this problem, that's just 3. And the slope is rise over run. So in this problem, we're going down 1 and then right 2. So that's down 1 and right 2. So that means the slope is negative 1/2. So this is the equation of the line, which we just figured out. Again, what makes it a hard problem is that they like wrote it this way, which is a strange way of writing it. So just find the equation of the line, and then you kind of just match them up. So if we look at it, they want it to be 1 over ax plus 6 over b. So in order for us to get negative 1/2, a would have to equal negative 2. So 1 over negative 2 is the same as negative 1/2. And then in order for this to be 3, b would have to be 2 because 6 divided by 2 is 3. So now we've got the a and b in this strange looking format that they have from our original equation. And then the final thing, because again, they add steps to things. So they just want us to do a plus b, and negative 2 plus 2 is 0. So the answer ends up being b. So just again, be careful. This is a hard problem, but they took a kind of an easier problem, would have been just find the equation of this line, and then they made it harder by putting it in this weird format and then asking us to find a plus b.
So we're just completing the puzzle, basic. It's like a puzzle, right?
That's all it is. Yeah.
Okay.
Yep. Yeah, it's just so the concepts, I mean, depending on like what math you've taken, but the concepts are all either algebra 1, algebra 2, some of algebra 2 and geometry. So it's not the concepts aren't what's advanced, it's the way they're asking the problems. They're taking kind of easier problems and making them more complicated. All right, so like an easy version of this problem would have just been doing this, which is definitely something we all should be able to do. But then they do this, and it's like you're saying, it's just we're trying to figure out what A and B are to like complete this puzzle. Okay. Number two. So again, these are just challenge problems. This is not related to systems yet. This is the equation of a circle. So what we need to know for a circle, which there will be a time towards the end of the 8 weeks that we will do just circles. Um, this is not given on the reference sheet, so you do need to know this. What I'm writing out now is the standard form of a circle. So this is an equation that we unfortunately just need to know. And then the area of a circle, that is given on the reference sheet. That's just area of a circle equals pi r squared. And they're telling us that the area of this circle is k pi units. So if I replace this a with k pi, and I imagine just I could just get rid of these pi's, and they want me to find k. But notice k is just r squared. Okay, so the first kind of realization in this problem is that if we know the formula for the area of a circle, that if it's k pi units, the k is just r squared. And r squared is the value that's over here when we get this circle in standard form. So that's like the first part of this problem is just recognizing that. So now the question is, how do we get it in that form? So I'm going to rewrite it. So it's x squared minus 8x. I'm going to leave a space. I will explain that in a second. And then it's y squared minus 4y. Again, I'm going to leave a space. And then I'm going to have equals 136.25. All right. So again, the problem has us just figuring out what r squared is, but it is not 136.25 because the left side is not in the appropriate form. To get it in the appropriate form, we have to do something called completing the square twice. Because notice these are perfect squares here. So to get something into a perfect square, you have to do this thing called completing the square that you would have done at some point, hopefully in algebra. But if you haven't done it in a while, you have to remember the way you complete the square is you add. So you take this number, this is like your b value, you take half of it, which is 4, and then you square it, which is 16. So if I add 16 here, that is going to make this a perfect square, and it will specifically be x minus 4 squared. Now, we don't really need to know that for this problem, but I just want us to see like that's why this works because I got it in this form. So the 16 was missing and I added it, I completed it, which means if I add 16 to one side, I got to add 16 to the other. And then over here, I just do the same thing. I need another perfect square. So half of 4 is 2, and 2 squared is back to 4. So I'm going to add 4. And again, just so we can see what that does, it makes it so this is now y minus 2 squared, which again matches the form. So this is what was missing before. It was not in standard form, and we're getting it in standard form. Well, if I add 4 to this side, I've got to also add 4 to this side. So it's like I'm just adding 20. So if I'm adding 20, I get 156.25. And back again, this is a hard problem. That's why it's taking a while. So back to our original kind of realization was that if they want k, k is really r squared. Now I have r squared because that is just the value that's here once I get it into standard form. So like the answer to the problem is 1. Now this is important. They want it to the nearest tenth. So that would be 156.3. That would be the like final answer. Also, when you are doing the SAT, on open-ended problems, they only allow for 5 characters. So that's why like the 156.25 would not have fit. So the decimal counts as a character. So this is 5 characters. So it's kind of why they asked us to round to the nearest tenth. So r squared is really 156.25, but we just had to round it. All right. So does anybody have any questions? Okay. All right. So now on to systems. So rest of the class, we're just going to talk about systems of equations. All right. And linear systems specifically. So here is a problem that we could just use Desmos. So on all the problems that we could use Desmos, I'm going to just kind of tell you that we could. Um, and we went over it last week. Using Desmos would just be plugging these two equations in and finding the intersection. But we also have to remember that it does take some time to do that. I'm just going to go over the other way for two reasons. For some of you, that might be quicker. And it's also important that we review the concepts for some later problems where Desmos will not be an option. So this is one where we could just do the elimination method. So I could multiply this by 2. So the first equation was 2x minus 4y equals negative 17. And then if I multiply this equation by 2, I get negative 2x plus 6y. And 2 times 27 over 2 is 27. And then I'm going to add the equations together. So the x's are eliminated. Negative 4y plus 6y is 2y. And negative 17 plus 27 is 10. And I can now see that y is 5. Now, unfortunately, that eliminates these two answers, but it doesn't tell me what these both have y equals 5. So that means I just have to go back to one of the equations. I'm just going to pick the first equation, and I have 2x minus, I put 5 in, 20 equals negative 17. And then I'm going to add 20. So I'm going to do 2x equals 3. And then I'm going to stop there because this is where we were talking about last week too. If we can stop the problem slightly early because we don't have to show all of our work, 3 divided by 2 is just going to be this 1.5, definitely not 15. So I just did that problem to review the elimination method. If you were doing it on the SAT, you have the option of using Desmos. And if you can type this in pretty quickly, then you're going to get the answer pretty quickly as well. So this is a really good problem for Desmos. But for right now, as we prep for the SAT, I think it's important that we just like review the different ways to solve problems. Because like I said, in a little bit, we're going to do some problems where Desmos is not really going to be an option. And these are the concepts that we're going to kind of be drawing from. Okay, let's take a look at another one. Okay, so here's a word problem. Um, so we have someone who is, we've got $10 bills and $20 bills. And on the way back to work, she lost the deposit slip. So all we know is that there were 19 total bills and 260 total dollars. So this one, we want to set up the system first. The reason we know it's a system, besides that's just the type of problems I'm doing tonight, but in general, we have two things that are unknown, right? We don't know how many $10 bills there are, and we don't know how many $20 bills there are. So let's say the X is the $10 bills, so 10X, and the Y is the $20 bills, so plus 20Y. So that's the number of $10 bills times 10, and the number of $20 bills times 20 is the total amount of money that we should have. So that should be the $260 that we have. And then the 19 bills, that's just the total of X and Y. So that's X plus Y equals 19. All right. So now again, you're at this kind of fork on a problem like this. You have to be able to set this up, but then you have to decide, do I want to just throw this into Desmos? And they're asking for how many $10 bills there are, so I would want the X value. Or do we just solve it quickly using the elimination method? So again, totally fine, just use Desmos, but I'm just going to review again another way to do the elimination method. I want to, the reason I'm doing that is because since we're solving for X, I want to eliminate the Y's. And I could also do it this way. I'm just going to multiply this equation by 20. So 20, 20, and then this becomes 380. And another option that I have when I do the elimination is I can just subtract. So in the last problem we added, because they were opposites. Now the y's are the same, so I'm going to subtract, and I quickly get negative 10x. The y's eliminate now because, again, I'm subtracting, and 260 minus 380 is negative 120. And again, this is where I'm going to stop the problem because x, if you can't do that in your head, it's fine, but you would just use a calculator. There's no reason to write it. When you do it in the calculator or in your head, you're going to get 12, and then we just want to circle the answer. Right? So just the earlier you can just realize that, okay, I don't need to write the rest of this down, either use the calculator or do it in your head, and then you could save time. And again, to reiterate, if you felt that at this step you wanted to just use Desmos, that's also totally fine. But either way, it's really important that in a word problem, we pay attention to what they're asking us for. So they were asking for X. It's simply because I made X the $10 bill one, right? So whatever variable you chose for the $10 bill is what you would be looking for. Okay. Next one. This one I chose for a very specific reason. One way to do this is, again, to use Desmos, find the intersection point, and then plug those values in here. But there is actually like a quicker way. So what I want you to do is look at it like this. Again, you could just use Desmos, but we're trying to like build like kind of the quickest way to do these problems. So on some problems, Desmos will be quicker, and then other problems, there's like shortcuts, or sometimes just doing it is going to be quicker than typing it into Desmos. So notice in the last two problems, they either asked me for the full coordinate, or in the word problem, I had to find one specifically. But in this problem, they ask for an expression. So usually when they ask for an expression, there's a way to get there without finding them individually. Okay. And most of the time that is done like this. So I want you to just check for this sometimes. I'm just going to add these together. Notice I am not doing the elimination method because I'm not eliminating anything. I'm simply just adding them together and noticing what I get. And when I add them together, I get 6x minus y equals 40. And then I want to think about how this is related to the thing that I'm looking for. And maybe we would notice that if I just multiply this by 15, because 15 times 6 is 90, I'm going to get 90x minus 15y equals 600. And then I'm just done. The answer is 600 because A and B are x and y. So again, they do those things. They just switch things like that. Don't let that like distract you. And when I see AB, I'm like, oh, that's just XY. So I'm almost ignoring the AB and imagining it just still being XY. So again, you can do Desmos, get the two answers, the individual X and Y, and plug them in here and do 90 times the X minus 15 times the Y. You'll get 600. But this is, again, just a nice, easy shortcut. And I know to look for it when they're not asking for the coordinate itself or an individual piece of it. They're asking for like an expression of it. And you could usually get it by adding the equations together without doing the elimination, just simply adding them right away, and then kind of multiplying, or, you just like manipulate it a little bit. So if you're looking at that thinking like, oh, I would never think of that, that's fine. Just I wouldn't either until someone like I saw that one time years ago that like, oh, if I just add the equations together, then you start to think of it. But again, if that's something that you're like, I wouldn't think of, you have Desmos for these problems. All right. So number 4 is a very typical systems problem where they're going to ask us, and we're going to see more of these going forward. They're going to ask us about the types of solutions to a system. And we should know that there are 3 possibilities. We could have one solution, where it intersects once. We could have no solutions like this one where it doesn't intersect, or we could have an infinite number of solutions where it's the same line. So another way to do this is we did a problem like this last week. We could use Desmos with a slider. I want to show you a different way to do it because I actually think you can do it more quickly. I believe the way that I'm going to show you would be quicker than even typing this into Desmos. And then remember, when you use a slider, you then got to check all your answers, or at least three of them. So here's kind of the deal. A no solution system, the way it has a certain look to it. And the look is this. The X's and Y's are the same, and the constants on the other side are different. So what I mean by that, let me make up one just to show you what I'm talking about. If I just make up, this is a different system. If I'm literally going to make this up. If I have 3x plus 7y equals 13 and 3x plus 7y equals 20, I know that system has no solution because the x's are the same and the y's are the same, but the number over here is different. So when something has no solution, you just want to picture a system that looks like that. An infinite solution would be the same idea, except these numbers here would be the same. So we'll get to one like that. So knowing that, all I want to do is think about, well, how could I make this situation where the x's are the same? So I'm going to look at that here. Well, I can do that just by multiplying the top equation by 2. So I'm going to get 4x minus 10y equals 16. And then the other equation is simply just, I'm going to keep that the same. And I'm going to look at it from the perspective of, well, what value of k would make it so that these are exactly the same? And that's simply just negative 10, right? If I imagine replacing k with negative 10, I'm going to have 4x minus 10y for both of these, but yet they're going to equal different numbers. So that would give us a no solution. All right, so that's why I think if you were able to do that real quick, you could get it even quicker than using Desmos with a slider and checking the answers. But that is also a fine way to do it. That's what I talked about last week. All right, so when you have these no solution problems, if you're going to do it this way, you're trying to make it so that the x's and y's have the same coefficients and the constant over here is just different. Okay, so we will see a similar problem in a minute where with infinite solutions. But before that, we have more of a graphing problem. So the graph of one of the two equations in a system is shown here. The system has no solution. Which equation could be the second equation? This one's hard to use Desmos because I feel like you would need to find the equation of this line to be able to type it into Desmos to get it to look the same. But I feel like that's a lot of extra work. What we need to know, another thing about no solution. All right, so when they're in standard form like the last problem, what I said, the left side needs to be the same and the right side should be different. Well, when they're in slope intercept form, no solution is just when they have the same slope. Because same slope leads to parallel lines, and parallel lines never intersect, so you get no solution. So what I want to do is, all I want to do is find the slope here. So the slope here is down 1, or sorry, down 2 over 3. So the slope is negative 2/3. Okay. Well, any answer that doesn't have a slope of negative 2/3 is out. And that leaves me with C and D. But notice D has a y-intercept of 3, and so does this. So D would actually be the exact same line. So that's there because that would be the infinite solution problem. That's like our distractor. So the answer has to be C. So same slope, different y-intercept is what would give you no solution. All right, so it's again important to know the different ways that you could have no solution because you want to just know one way because they can give it in different ways, right? They could give them in standard form, or they could give a problem like this in slope intercept form, uh, or there could be a problem where it's just best to use Desmos. So we really need to know like what we're looking for in each situation. Okay. So now when we move on to number 6, first, they're in standard form and they're talking about infinitely many solutions. So when it's in standard form and you're talking about infinitely many solutions, that means that the x's, the y's, and the constants all have to be the same because they're the same line. So if they're the same line, then again, like I said, the x's, the coefficients of x, the coefficients of y, and the constant on the right have to all be the same. This is a problem where they make it very, very difficult to use Desmos. So if you try to use Desmos here, it might be a fun to try that, but I don't. It's going to take a while because first of all, you're going to have two sliders, and then you're going to have to mess with both sliders to try to get it so that the lines are on top of each other. And we can't use the answers because the answers are after we've already added A and B. So there'd be no way to look at an answer and to know what A and B were. So this is one I would definitely stay away from Desmos. So what I would do is what I said before, just make it so that they look the same. Well, I can't do anything with the X's because I don't know B, and I can't do it with the Y's because I don't know A, but I can make these two the same. I could just multiply this equation by 2. So my first equation remains the same. And also, I'm writing this out just so it kind of looks nice for you. On the actual test, I probably wouldn't even rewrite this because, again, you're really trying to save time. Um, So I get 2bx plus 10y equals 12. All right. So again, infinitely many solution problems are in standard form like this are when the x's, the y's, and the constants are all the same. Well, the constants are the same, so that's good. Now, in order for the y's to be the same, a would have to just equal 10. In order for the x's to be the same, 3 would have to equal 2b. Right? These two would have to be exactly the same. And then if I just divide by 2, so then I get 3 over 2 equals b. You can just use a calculator if you want, or if you just know 3 over 2 is 1.5. We're doing a plus b, which is 10 plus 1.5. And again, I would probably not have written this on the actual test. And then you would just add them together to get 11.5. All right, so once again, we're just really trying to understand these types of solutions to systems, whether there's no solution, what that looks like in the different forms, what infinitely many looks like in the different forms, and eventually we'll get to one where they talk about one solution. Okay, do we have any questions about anything so far?
No.
Okay. All right, number 7. Um, this one looks confusing because I got a P, I got a Q, and I've got X's and Y's. Um, it says that the two lines intersect at 4 comma Y, and they want the value of P. I'm not sure. Yeah, I don't think that we could use Desmos here. Maybe. It'd be really hard because again, we'd have two sliders. We'd have to mess with the sliders to try to get them to intersect where the x value was 4 and then figure out the y value and then get that corresponding p. Maybe that's possible. I honestly didn't try it because I think there's a much easier way to do it than kind of work your way through that. So the first thing is, and this doesn't, I think I mentioned it last week. This does not apply to systems. This applies to any problem where they give you a point. So if you see a coordinate pair in a problem, the first thing you should do is just plug it in without even knowing what the problem is saying. That's going to be the way to get started. So this means I want to replace each x with 4 and then each y with y, but that'll just stay the same. So I'm going to replace each x with 4. So this is 16 minus 5qy equals 36. And then if I replace this x with 4, that's 4p plus 10qy equals 54. Okay. And they want the value of p. Well, that means I do not want q or y to be in the problem. All right. Well, they set this up perfectly. Again, if once you see what's going on, the problem's going to work out perfectly because they're set this way, right? Look how the QY, this one's 5 and this one's 10. We're just going to get rid of them by doing the elimination method. So I'm going to multiply this by 2. So that gives me 32 minus 10QY equals 72. And then again, I'm just going to write this underneath. And then we're going to add the equations together. All right. So again, the reason I knew to do that was because I needed the P to stay there. And in order to get P, I need everything else to eliminate. And these are now going to eliminate. Now, this is important. These don't combine. They're not like terms. So I'm just adding them. So I'm just writing 32 plus 4P. And that's going to equal, when I add these together, which is 126. And now I'm going to solve for P, just pretty simple linear equation. So take away 32. So 4P is 94. And then divide by 4. And P is, I did it already. This one is a decimal. So this is 23.5. Another reason why it'd be very difficult to use Desmos to figure out to make a slider go to 23.5. It's pretty unlikely. All right. So I would stay away from Desmos and the slider on open-ended problems and when there's multiple sliders to do. You're just adding a lot of guessing and checking when, again, you could do it this way. But this is a hard problem. So there's these things that I think I talked about last week, these like cues. So basically, when they come up, they kind of like tell you what to do. When you see a point, just plug it in and then the problem might make a little more sense, at least get you like a way to get started. I feel like that's the biggest thing on the harder problems is students don't know how to get started because the problems look different than they're used to in school and they just they're used to just looking at a problem and thinking, well, I know how to get going here. But with these problems, there's a lot going on. So again, focus on the thing that you can do, which in this case is just plug in the point, and then hopefully the problem becomes more clear. Okay. So number 8. Okay. So in the system below, A is a constant. What is the y value of the solution to the system in terms of A? Okay, so again, I don't really see how Desmos is going to help us here. We really need to understand the elimination method. They want the y value. And the y value in terms of A, it looks like it's going to be pretty complicated, but don't worry about that. Just again, get started. If they want the y value, we need to eliminate x. So we're going to eliminate x by multiplying this equation by 5 and this equation by 3. So this is why I went over the elimination method earlier. Unfortunately, you can't just say, I'm going to use Desmos for all systems problems. You still need to know the elimination method. You might be able to use Desmos for a lot of it, but the way they set these problems up, they're going to make sure that you know these concepts. Um, So that's why it's important to still remember the concepts. All right, so this one gives me 15x plus 20y equals 30. And then I'm going to multiply this bottom equation by 3. So that's negative 15x plus 3y equals 3a. Again, I'm eliminating the x because they want to know why. So I'm just going to continue like I would in school, except in school you probably wouldn't have had an a here, right? They don't usually do problems like that, but just keep going. So I'm adding to get rid of these. So I'm going to add these and get 23y. And then I can't add these because they're not like terms. So I just write them like 30 plus 3a. I think that trips students up too. They're not used to seeing it in that format, but you just write it out when they're not like terms like that. And then they just want the y value in terms of a. Well, I just got to solve for y. So I just divide by 23. And again, I have the 30 plus 3a and I'm dividing by 23. So I might be able to just see that the answer is a, without having to write this. If it's that helpful for you, you should do that. But if you can skip that, then again, those seconds add up. All right. So it's again one of those takes an elimination problem from school that might be pretty easy for you and just complicates it with this a here. But just go the same way that you would normally go, and it'll kind of just work out. Okay. All right. Now on to we got some more complicated problems. So number 9 is it says um, which of the following points lies on the graph of each equation in the xy plane for the given system? Okay. We don't have to do what I'm about to do, but I want to explain something. Imagine we multiplied this equation by 5. Again, this isn't necessary to do the problem, but it is necessary for me to kind of explain something to you. Notice it's the exact same equation. That means there's an infinite number of solutions because we have the exact same x, the exact same y, and the exact same constant. Usually, in a high school algebra or algebra 2 class, when you do this, definitely almost always in algebra 1, all you have to do in a problem like this is say that there's an infinite number of solutions. You would just write infinite solutions or something. And you'd move on and get the answer correct. But the reality is there is a way to, when there's an infinite number of solutions, there's a way to express the answer as a coordinate pair. And a lot of times students have never had to do that before. If you have, then that's great. But a lot of students I come across are like, well, I've never had to do that. We can just write infinite solutions, and then that's all my teacher taught me. So this is a skill that is not usually taught, but it's something that you can do that probably should be taught because the SAT definitely wants you to know how to do it. So the idea is this. We come up, since there's an infinite number of solutions, we come up with a general ordered pair with this like other variable that represents all the solutions that would lie on this line because it's just one line. You graph one line and then the other lines on top of it. And the way it works is there's actually in an open-ended format in like a class where, not open-ended here where you'd have to put in numbers, but like open-ended in a regular math class. There would always be two acceptable answers. We could have made this R value the Y, or we could have made it the X. Like we would have that option. So A's answer doesn't really make sense, but we'll see we'll see that in a second. So what I'm going to do is I'm going to just show you both so that you can see how I know that an answer is wrong. So I'm just going to I think the first one I want to do is imagine that the R was the X. And I want to figure out what this Y coordinate would be. So I just go to my one of my two equations. I'm going to pick the easier one, the first one, and I'm going to replace r or x with r. And then I'm just going to solve for y. Because I'm going to imagine the x is r, and then I'm going to think, well, what is y in terms of r? So I'm going to just subtract the 2r to this side, and then I'm going to divide by 3. When I divide by 3, I'm going to divide everything by 3. So then what would go here is negative 2/3 r plus 7/3. So if I make r the x coordinate, this should be the y coordinate. Well, notice the two answers that have the r here, this y coordinate is wrong. This one used 3/2 when it should have been 2/3. And this one used positive 2/3 when it should have been negative 2/3. This one also used 7/2, and that's wrong. So those answers are wrong. Now, this answer doesn't really make much sense to me, but just to kind of show you why B works, the other way to look at a problem like this is to make the y equal to r. So if I do that, I go back and I have 2x plus 3r equals 7. And then I just solve for x. So 2x equals negative 3r plus 7. And then I just divide everything by 2. And the x coordinate here in terms of r is negative 3/2r plus 7/2, which matches answer choice B. So again, just to recap, if you get infinite solutions in school, they a lot of times don't ask you to do this, but they could ask you to give the answer as an ordered pair with like a third variable in it. And the two acceptable answers would be these two. But we didn't know which one, so I just did both. You could have got lucky and did this one first, and then you would know the answer is B. Again, the A answer doesn't really make sense that one of them is not R. So if I were actually taking the test, if I had chosen this one first, I would have realized that it was B without having to do this. But for this, I want you to kind of see all the concepts and understand like where these answers are coming from. All right. Couple more problems. So let's take a look at number 10. Okay, so we have infinitely many solutions. And I'm going to show you a different way to do this. Okay. And the way that, some of this you might be able to do in your head, but I'll write it out just a little bit. So I showed you before that infinitely many solutions would mean that in standard form would mean that everything ends up being the same. So I could do that. I could multiply this 12 by negative 3. But then I'm going to get a lot of like fraction answers, and then it wants me to divide b by a. So then I'll end up dividing fractions more. And I know you have Desmos or a calculator, but I just want to show you a different way to do these problems. So another option we have is they would have infinitely many solutions if they're the same line. And if they're the same line, that would mean their slopes were equal. And the way that I can find their slopes is I can just get them in slope intercept form. So like this one, I could do negative by equals, I could move the ax to the other side. Actually, no, I'm not going to do that. Let's do this as quickly as possible. The way I would do this is I want the by to be positive. So I'm actually going to add the by to the other side and subtract 12 to this side. So hopefully that makes sense. All right, so instead of having to divide by a negative, I want this to be positive. So then I just divide everything by b. And again, the only thing I want from this is the slope. And the slope is the coefficient of x. So a over b is the slope of this line. And now this one, I want the slope of this line. Well, this one, I'll just do it like this. 7y, I'll move the 2x to the other side. And then I'm just going to divide by 7. And again, all I want from this is the slope. So the slope is negative 2 over 7. And the slopes of these lines have to be equal to each other. So a over b has to equal negative 2 over 7. But they want b over a. So this is a way to get it without finding a and b individually. If I want b over a, I'll just flip this. So if I flip the left side, I got to flip the right side. So it becomes negative 7 over 2. So that's why I chose to do it that way. If I had made them the same, I feel like I would have had to do more work. But if that's easier for you, that's fine. This is another one that's kind of hard to use Desmos because um, you might be able to. But again, you're doing a little more guessing and checking, I feel like. So this is just another way to look at this. Infinitely many solutions, the slopes are the same. So you do have to get these in slope-intercept form. But if you can do that quickly, or some of you might be able to look at it and figure out the slope in your head, and then you definitely want to do it this way. Because once you get to this, the answer is easy. You just have to flip it. Okay. All right. Down to our last two problems. So we got another word problem. This one I wanted to go over because this has some common mistakes that I see a lot. Um, so the company currently has 3 times as many junior accountants as senior accountants. Well, I'm just going to use J and S for my variables. I see this a lot. 3 times as many junior as senior. And this is wrong. We read it that way, but this is not correct. That's the mistake that I see. And then that mistake will happen again on the second equation. The reality is, I look at it like this. I have juniors and I have senior accountants. And if there's 3 times as many juniors as seniors, there's more juniors than there are seniors. I have to triple the number of seniors for it to equal the number of juniors. Right. So if we just read it quickly and write a sentence, that's what I see a lot. I see a lot of 3 times as many juniors. But it's really, you're multiplying the seniors by 3 for them to equal the juniors. And if you imagine a value for S, you'll clearly see that the J, there will be 3 times as many juniors as seniors. Okay. So that's why I chose this problem because I see that mistake a lot. Okay. So now the company plans to hire 140 more senior accountants. So that means the number of seniors is going to increase by 40. Sorry, 140. And so that the number of junior accountants is now twice the number of senior. So again, we'll have to double the amount of senior to equal the number of junior, right? We want the juniors to be twice the number of seniors. So whatever the seniors are, now they're S plus 140. That'll have to be doubled for it to equal the current amount of junior. That's the hard part. The easy part is solving the system. Um, I know they ask for junior, but I'm going to solve for S because I can just do a simple substitution. So I can just do 3S. I can place that here. And then over here, I'll distribute. So 2S plus 280. Subtract, so I get S equals 280. Be careful. This is another common thing, especially on a time test when you're trying to like move through it. When you solve your initial algebra, that might not be the answer. In this case, it's not because they want juniors, not seniors. So again, juniors is 3 times that, and 3 times this is 840. All right. So the actual answer to the problem is 840. Okay. On to the last one. This one's a little bit little bit tricky. So they've got a system of equations already that's there, and then a new graph is creating using this system and then this equation. Well, I'm going to take this equation and I want to be able to graph it. So I'm simply going to just rearrange it to get y by itself. I'm going to do what I did in the problem before. I want the y to be positive, so I'm going to add it to this side. And I want this 2 to be over here. So that's 2x minus 2. So then I want to graph this because how many solutions will the resulting have? A system is where all of them intersect at one point. So what I'm going to do is find out, is there one point that all three lines will share? Well, I have these two already graphed. I just have to graph this one. So notice one thing that they like to do whenever there's a graph, always question the scaling. 'Cause they're going to do as many things as possible to see how well you're paying attention, especially in this, like when it's timed. 2x minus 2, the y-intercept is negative 2. That's here. They're scaling this by twos, right? 2, 4, 6, 8. And then the slope is 2, which means you go up 2 over 1. Well, as long as the x and y are scaled the same, I can still count two spaces over one space. That still works out to be the same. And notice the x and y axis are scaled the same. So I'm going to go up two spaces over one and notice that that puts me right there. So whatever, I'm trying to graph this straight, but it doesn't really matter. We can see that there's this one point that's going to be the intersection of all three of them. So there's going to be exactly one solution. It doesn't matter if there's any other like the intersection has to be the same for all three lines for it to solve the full system. Even if two of the lines intersected somewhere else, that wouldn't count. It has to just be one. Or if this line was like over here, then it would just be none because it needed there again, there has to be the one point shared by all three for it to be a solution. Okay. All right. Any questions?
There was a problem that was near the beginning that I didn't finish writing out. There was something that I missed. Could
Yeah,
you
yeah,
go
yeah. What
back up?
number?
I think it was two.
Yeah. This one?
Uh, no, it was base. It was for the it was like completing the square. It was a completing a square equation.
Oh, the second, I see. The second,
Yeah, that one. I'm still confused on where you got the value 156.3 from. I didn't finish like that equation while you moved on.
oh,
I didn't want to interrupt with.
do you see where the 156.25 came from?
Yeah.
So that's the answer to the problem, but they just wanted it rounded to the nearest tenth.
Oh, okay.
So I just the five makes the two go to a three. That they asked that because you when you type it in the open-ended in the on the digital SAT, they only let you use five characters. So this would have been too many. So that's why we only used one, two, three, four, five.
They only let you use five characters.
Yeah, on open-ended questions.
Okay.
So if you like tried typing in the 0.25, it would be even though you did all the answer work correct, it would still be marked wrong because it'd be and they'll make that clear when they go over the directions.
Okay. Thank you.
Yep, you're welcome. Any other questions?
Do you know where we can access the last recording?
Yeah, everything's on YouTube. So if you just joined us tonight, um, here's all of our stuff. TikTok's back, so I'm putting all this stuff. I put a lot of videos on TikTok, but on YouTube. If you find us on YouTube, or I'll send out an email every Thursday, and in that email, I'll put a link to the recording from the video.
Yeah.
And if you just follow that link, the other YouTube video will be there.
Thank you.
And if you just joined tonight, I can make sure I email that to you as well.
Thank you.
You're welcome. Okay. All right. So again, here's all of our information. If you're looking for anything else, Again, so yeah, Thursday I will email out next week's problems as well as the link to this video, and I'll send out like the answer key as well in case you didn't get everything.
Do we just keep using the first link that you sent us for that Zoom?
Yes. Yeah,
Okay.
my Zoom, yeah, it never changes.
Okay. Well, thanks.
Okay. All right, everybody. Well, thanks for coming. And again, look out for my email Thursday. Check out the YouTube, and I will see everybody same time next week. And again, yeah, it'll be the same link for Zoom every week.